have 3 examples that I'll work through with you. I will put each one on a separate video so you can watch one or all of them, depending on what you need. So here's the first example. The population of a certain animal species decreases at a rate of 3.5% per year. You have counted 80 of the animals in the habitat you are studying. So the first thing you need to decide is whether you're going to use your exponential growth equation or your exponential decay equation. If you decide it's exponential growth, then you also need to decide, are you going to use your standard yearly growth equation, or do you need to use your compound equation? So let's go back and reread the problem. Population of a certain animal species decreases. So right there, that tells you that you should be using your exponential decay equation. So if it says write a model, I'll say y equals, my initial amount is 80. I'll say 1 minus 0.35 because my rate is 3.5% raised to the t. And I'm going to declare my variables. Say t is time in years and y is my population. And there is my model. The next thing it says is to graph this equation. So I'm going to simplify this parentheses. It'll be easier for me to put it into my graphing calculator. And it makes the model a little bit more succinct. So if I go over here to my graphing calculator, you can see I've already put it in, 80 times 0.965 raised to the x. I'm going to set my window. I set my window from 0 to 60 and my y's from 0 to 100. Setting your window is a little bit of trial and error. You need to play with it and see what looks good. I'm actually going to go back to my y editor and get rid of this number right here. And if you graph it, you'll see here that this is a nice graph. If we were then to transfer this graph onto paper, I'm going to put down, I went from 0 to 60, I went to 100. This here is time in years, and this here was population. And my graph kind of started like this and went down like that. So there would be my exponential decay equation. Estimate the number of years. So now they're asking me to solve for t until the population is below 15 animals. So this here is they're giving me a y and they're asking me to solve for t. So my equation would look like this. 15 equals 80 times 0.965 raised to the t. Once again, now my variable is an exponent. I do not know how to solve that algebraically right now. Maybe next week you will. But right now we can only solve that graphically. So we go to our graphing calculator. We'll go to our y editor. We'll put 15 here. We'll go ahead and take a look at our graph. And where they intersect will be our answer. So if I go to second trace or second calc, number 5 is my intersect. It's blinking on the first curve, so I'm just going to hit enter. It jumps down here to the second curve, so I'm going to hit enter again. It asks me to guess, so yes, of course, I'd like you to guess. I'll hit enter again. And it'll give me my answer of 46.9. So I'll just round that to 47 years. And anything after that, my population will be below 15 animals. All right, I will do example 2 in the next video. If you have any questions, let me know.